Okay, so on page 34, 35 in your notes there, we're going to look at these satellite dish and a bit of a picture of that. But first, let me show you this. Let me show you that screen. You can see the actual picture of the flashlight. So there's a flashlight, and this would be the head of the flashlight where the beam of light comes out. And you can see the satellite dish, which is kind of wide. This one's more of a narrow parabola, right, where maybe the A number might be more than 1. So it's going to be more of a stretch probably for the flashlight, but more of a shrink here on this one for the satellite dish. And, if we think about this flashlight, the actual, head is not where the source of the light is. The source of the light is the actual light bulb, right? That little light bulb, there's a light bulb. It's in the middle, right there at the kind of the bottom of the head of that flashlight. If you took off the head, some flashlights you're able to do this, where you can kind of unscrew the head and pull it off, and it still have the flashlight shine. What happens to the light? Just goes everywhere, right? Just it makes the light go everywhere, and then you put the head back on, and now it's a beam again. So that's the application of a parabola. The parabola allows it to be a beam of light. And that's what we're going to see here on page 34 and 35. So let's take a look at what this is here. So on 34, this is the one that is the satellite dish. Okay, so let's say you have a dish on your house, on the side of your house for your cable, for your TV, for your internet, or whatever it is. That means you need to receive the information. You're receiving the information from a satellite out in space, which is also getting information from some other place where, the dish network is actually housed. So the dish on the side of the house, though, it would be a receiver. It's receiving information. The problem is that the actual dish, the parabola shape, it's really more of a catcher's mitt than anything else. It's catching the information. So if you look at this shape here, the actual shape of the parabola, you can see the rays. Now these would be like radio waves coming down into this. So this is what is happening. You have the radio waves coming down from the satellite. So these rays are coming down, and the bowl of the dish is like catching all of them, okay? But then it's taking all that, and then it's going to bounce it or reflect it off the dish. You can see the red little arrow here. Ray 1 hits here, and then it's going to go this direction towards the y-axis. Ray 2 would do the same thing. It would bounce here and then go up towards the y-axis. Ray 3 would do the same thing. It's going to bounce here and go towards the y-axis. They're all going to go towards the y-axis, and they're all going to go to the exact same point on the y-axis. And that's a special point. We call it the focus point. Okay? Everything's focused. All the rays are focused on that one point. Now, that would be the point on a satellite dish where the wires are hooked up into. So that way it's getting that information in that focus point to then send through the wires that's going to go down eventually into your TV or devices, your computers, into the house. Okay, that's what's happening. The dish catches it, focuses it into that little focus point, that little receiver, and that sends the information into the house. There's the next one on 35, shows you the flashlight. So here, this one, this is a flashlight. Now, we have it says the bulb is right here in the middle. So you can think of the bulb is right there. It goes off, and light goes everywhere. But because it's inside of this parabola shape, and if you notice, if you ever look inside of a flashlight head, everything's really reflective, right? It's a reflective surface. It almost looks like mirrors inside of there. It's shiny, silverly, it's silver, and it's all reflective. And that's what's happening. It's going to reflect all the light rays, all the beams of light out towards into one straight beam. So you can see on this one, beam 1, it shines this way, hits the side of the parabola, and then goes straight out. Beam 2 would do this and then hit and go straight out. Beam 3 goes this way, and we go straight out. They'd all go exactly straight out. So why don't you go ahead and write this down or draw this down, that these are all going to kind of go, if you can follow this line a little bit, it looks like it's kind of headed towards 1. That would be a good point to use. Put a point right here at 1. Let's go ahead and draw a point. Let's do a different color. I'll do mine red since this line's in red. So put a point. This is on 34, and then extend this arrow over to it. It's going to go over to it, and then from here, let's make this one go all the way up to 1, and then over here, I'm going to make this one go up to 1. These are all going to go into the focus point, and maybe you can draw arrows this way as well. They're all arrowed into that focus point. That's what's happening with the satellite dish. Okay, so do that on that one, and on 35, let's do it on this one where now these ones, we already have beam 1 done for us. Let's do it to beam 2. This one, beam 2, this goes down here, but then it's going to go straight up and out. So try to draw as straight of a line. Mine's a little crooked, but do your best. This one, beam 3, goes this way, but it's also going to go straight up. It's not going to go out on an angle, it's going straight up. All the beams, because there's hundreds of beams of light, obviously, going everywhere, they're all going to go straight out. And that's why you can see on the flashlight that it's going to go straight out. In fact, when we saw this picture of the flashlight here, this was against the wall. Notice the shape of the light when you stick a flashlight against the wall. Look at right there. You can see the parabola shape even on the light. But the beam of light goes straight out. And eventually it kind of does that parabola shape where it goes out, but then it kind of fans out a little bit too, right? When you shine it, it doesn't just go straight on there. On mag lights, you can kind of turn it and you can change the beam a little bit. They've sophisticated them that way, but definitely you're going to see a parabola shape for the most part. Oops, that's not where I want to go. Here. All right, so let's take a look at the notes now this is on page 36. The top of 36, we talked about this focus point. The focus point is the light bulb of the flashlight. It's where the source is of the light, or it's the receiver. So it's either the sender or the receiver. That's the focus point. And on the parabolas here, what is the focus here? We can say this as a definition. It's a fixed point inside the parabola and located on the axis of symmetry. That's the focus point. That's, aside from the vertex, that's the other most important point really on a parabola in real life. That focus point, because that's really the sending or receiving thing for this real life application when you actually want to apply a parabola to real life. The directrix. Now this one is not really as important, I think, as the focus. The focus is definitely important here. Directrix would be a line. It's a line that's going to be right behind the parabola. It's located behind the parabola. It's also perpendicular to the axis of symmetry. And I put there in green that the vertex is always exactly in between those two. So the vertex is always exactly in between the focus point and the directrix. It's an equal distance from them. So if, like, we think of if the vertex was on 0, 0 and our focus was just maybe 1 point up on the y-axis, then the directrix would be 1 unit down on the y-axis. It would be right just 1 unit away from that vertex. If the focus is 1 up, the directrix would be 1 down. So the vertex is right always in the middle between these two. Now we're going to see in this lesson that so far we've only seen parabolas opening up or opening down. What we're going to see in this lesson is sometimes the parabolas are going to open left and open right. Now we'll see what's different about those that open left and open right. Now one other thing I want to show you here back on this little screen with these is this right here. Notice this is like a cone. We got a cone here. If we take a plane and we slice the cone, basically if you took a knife or something like that and just sliced it down, what that's called is it's called a cross section. You're taking a cross section of some solid figure, okay? And what you get when you take the cross section of a cone right here, as you can see in red, that you get a parabola. And so that cone would be like the shape of maybe inside here where you have your light, your beam of light. If we were to, spin this and get that head of the flashlight, a cross section, if we took a cross section of the head of a flashlight, that's going to be a parabola. So sometimes they might be, you might see that word, and we're going to see that on the last one here today is It's called a cross section. We're going to see that applied. Oops, again, I did that again. I'm going to come back over here. Okay, so in the core concepts here, we see these two are opening up, but now here these two are opening down. So here's where we see what's different about the one that's opening down. Now, these two here are all about the vertex being at the origin. And it gives it to you kind of a simple way where it just is kind of like y equals ax squared. So now remember that. We know about y equals ax squared. That's basically what we have on this one. So if we look at the vertex form, so remember we've seen this before, y equals ax squared. We know about that. That's where your vertex is at 0, 0. There is no h, there is no k. So we would say our vertex is at 0, 0. And this a may be negative. If it's negative, we know it's opening down. If the a is positive, we know it's opening up. A could be more than 1. If that's the case, it's going to stretch, and get narrower. A could be less than 1, like a fraction, 1/2. And then it gets wider. Okay, that's what happens there with A. But now we're going to notice that we see some opening down. What's the difference here that happens? All that's going to happen is we're going to switch the x and the y. You switch the x and the y, and now we write it this way. X equals a y squared, basically. You switch the x and the y. Now that's a sideways one. That's opening left and right. Okay? A is still going to be doing the same thing. If A is positive, it's going to open right. If A is negative, it would open left. If A is greater than 1, it's still going to be narrow. It's going to be a narrower. And if it's less than 1, it's still going to be wide. It's still going to be a wider parabola. But it's just going to be opening left and right if you have it like this, where you switched the x and the y. So that's where in this one we're switching x and y and getting them open to sideways. We're opening them sideways when we do that. Now there's another thing here, which is this right here. Instead of a, notice what they put. They put right here a 1/4 p. So basically this, a is equal to 1/4 p. You can write that down there because that's important. So in this form, when we're talking about if we have a directrix or we have a focus or a directrix, then we want to notice that A is really going to be a 1/4 p. And so what we're going to do is we need to figure out what is the p here. That p is going to be a distance, and the distance right here, I showed it to you on this one, that p is the distance from the focus to the vertex and the vertex to the directrix, because remember, those are always the same. Vertex is right in between the focus and the directrix, so this is a p distance right here. And when we want to know, well, what is p? P really is always going to be from the vertex to the focus. So you don't want to go off from the vertex to the directrix so much, because that would be the opposite sign. That would be the wrong way. P is always going to be from the vertex here. So in this case, p would be positive, because you're going up from from vertex to focus, you're going up, so p would be positive. But on this one, from vertex to focus, you're going down, and p is going to be negative. Do you see how it says right here? P is going to be greater than 0, positive. P is going to be less than 0, negative. Okay? So we can think of this is going to be, so it's always going to go from vertex to focus. That's the direction that you want to see the p in. Okay? I mean, you're still going to see the p with the directrix here. It's just the opposite sign. It's the opposite. It's the wrong way, so it'll give you the wrong sign if you do that. Same thing over here when it's going to open this way. It's going to be, the p is going to be this way, vertex, vertex to focus point, or this way, vertex to focus point. Go from that. That's your p. Once you know your p, you can plug it into here, 1/4 times whatever p is, and simplify that, and that gives you what your a number is. Okay, so that's how you can kind of write an equation of this. Or if we have an equation and we need to figure out what is the focus, well, then we just need to figure out, well, what is p? We might need to solve for p. Now I put these equations on the side over here because these ones what we did here is just solved it for the x squared or solved it for the y squared. A lot of the time they like to see the equations when they're specifically talking about the focus or directrix, when they give you that kind of information, they like to see the equations this way, where the x squared part is what's by itself, and then you have everything else on the other side. So it's just a different way of solving the equation, a different way of looking at the form of the equation. It's kind of more like the focus and directrix form. Now this other one on this core concept just is where you have an h and a k. So our vertex is not at the origin, it's somewhere else, but essentially it's all the same thing. Here's like our vertex form, right? We know this. We see our h, our k here. Here's our a number, but we are using the 1 over 4p, but we know that's the same thing as a right there. And if we're opening them left and right, then we're going to switch the x and the y. But what do you notice here? When you switch the x and the y, what happens to h and k? Don't they switch as well? So that's what's going on. Remember, if you're going to say, well, I'm going to switch the x and the y so it's going to go sideways, you're going to have to also switch the h and the k numbers, okay? Because the h is always connected with the x coordinate, and the k is always connected to the y coordinate. So if you switch the x and the y, you're switching the h and k also. So that's what's happening down here, as you can see that. And again, I solved them for the squared part, the squared parenthesis. You know, that's what I'm doing here to get to this. It's just a different way. Again, you can kind of rearrange this equation, and a lot of times they like to have the equation written out this way, where your squared part is by itself, and then everything else is over on the other side. It's also an easier way sometimes to figure out what p is, because you don't have to worry about the fraction. All right, so let's get into the extra practice. Okay, so now I did draw these just to give us a visual of this. We don't have to draw them, but it's very helpful. I would suggest to always draw it out so you can kind of get the idea and you can actually see it, because for me that's just so much easier to see what's happening. So I did a table, or not a table, a coordinate plane here, x-axis, and this is the y-axis. And what I did, I just plotted these points. I plotted the focus point, 0, negative 8. So if my origin is right here, I just, on the y-axis, 0, negative 8. That's the point there. I just put it in red. That's the focus point. And then it says that the directrix is the line y equals 8. So that's going to go up on, where is y equal 8? That's up here, 8 units above the origin. And it's a straight horizontal line that goes right through that. So just from having that, I can conclude my green parabola has got to open down, because the focus has always got to be inside of the parabola. The directrix is always going to be behind the parabola. So it's got to open this way. It can't open right or left. It can't open up. It has to open down in order for this point to be inside of it. So since I know it's opening down, that's a helpful thing, because that tells me what kind of equation I need to use. I'm going to either use the one where it's the normal one that we've been using so far, where it's always x squared, right? If I noticed that it was going to open left or right, well, that's when I would want to use the one that's switched, where the y is being squared. Okay, so I know to use this equation, the x squared one, where I'm going to use the one that I wrote down on the side, where it's x squared equals 4py, because this one you're able to be able to write the equation very quickly in this form. This is a form they often like to have because the x squared is by itself. We just need to figure out, well, what is the p number going to be? Remember, the p number is going from the vertex to the focus. So from 0 to negative 8, that's in a negative direction, so our p has to be negative 8. And now all I have to do is plug in p into that form of the equation. So x squared equals 4 times negative 8 times y. Well, 4 times negative 8 is negative 32. So x squared equals negative 32y. So that's one way we can write the equation. Now there is the other way, that the one that was typed on your core concept. That was where you had the y is equal to 1 over 4. Basically it's like this here. It's y is equal to 1 over 4 times p. I already plugged in p down here, the negative 8, and x squared is here. And so now you see, well, 4 times negative 8 is negative 32 down there. So here's another way we can write the equation, and we're not wrong. Okay, one is solved for x squared, the other one's solved for y. Okay, so there's two ways we can write this equation, This is the way we're more used to writing it, where it says y equals. This is now a way that sometimes you might see it written, where x is squared first. X squared equals this. On number 2, again, I plotted the vertex. It gives me the vertex and the focus point. It gives me the 2 points. So I don't have to worry about the directrix on this one. My vertex is at 0, 0. My focus is at 0, 1, right there. So from the vertex to the focus, I know it's got to open up. So I know this parabola opens up. So that's helpful. I know I'm going to use the same equations as I'm doing over here, where x is being squared. If it opens left or right, then I'm using the one that's when y is being squared. So now I can just use that same equation. This x squared equals 4py. P is 1. It's positive 1 if you go from the vertex to the focus. That's going up, so it's a positive direction. 1 unit. So we're going to plug in 1 for p. That's very easy. Just 4 times 1 is 4. So x squared equals 4y. That's one equation we can have. The other way, if we wanted to have y first, where it's y equals, we would do it this way. We'd say y equals 1 over 4 times the p this way with the x squared. This is where it's got to have the fraction for the a. And that would just make this a 1/4. So the other way would be like this. Y is equal to 1/4 x squared. And so this way it's easy to see what the a number is, and we can see from that a number how wide this parabola is. It's a wider parabola. So definitely this one we're more familiar with. But these ones you might see sometimes. That's why I wanted to show them to you. All right, we're going to get into now doing some graphing on the next part. Okay, so here we're looking for 3 things to identify and then to graph the equation. I think it might be a little easier to actually graph the equation first and then go ahead and write down what the 3 things are that we're trying to figure out, which is the axis of symmetry, focus, and directrix. So that's why I put them all underneath here. We're going to fill this in here eventually. But the first thing would be to just try to graph these quadratics. We know they're going to be parabolas, but again, like I said, sometimes they might be opening left or right. Do you see one in here out of these 3 that's going to be opening left or right? Can you tell which one's going to open left or right? There is one of them. Is it 3, 4, or 5? Yeah. Which one's got the y squared? See 4? 4's got the y squared. So that's when it's going to open left or right. Okay? All right, so the first thing on number 3, we might rather have the y by itself, right? We might like it where the y is by itself and we can see the a number. So we might want to do this. Get rid of this -2 to solve for y, which means I need to multiply both sides by a -1/2. That's the reciprocal of that. If I divide by 2, it's the same thing as multiplying by 1/2. It's got to be negative. So I'm going to multiply over here also by a -1/2. And so we can write our equation as y equals -1/2 x squared. And so that might be more of a form. Now we can see what the vertex is from this form. Definitely, there's no h, no k. So it's just going to be 0, 0. We can put a point right here. We know it's got to have a vertex at the origin. Our a number is negative, so that tells me which direction is it going to go. That's up or down? Down, yes. We're going down when it's negative. And then we have the 1/2, so it's going to be wider than our normal parent graph. It's going to get a little bit wider. So notice the numbering though. It's going, every box is worth 2. So be careful about the way they number these sometimes. Every box is worth 2. So let's just go one box, which would be 2. So if I go 2 to the right or to the left, normally I'm going to square 2. 2 squared is 4. And so normally I would go down 4, but what I need to do is I want to go half of that distance. That's what the a number is. The a number tells me to multiply 2 by half. Half of 2 would be 1. Or sorry, half of 4, sorry. We're at 4. I said we're going to go 2. 2 squared is 4. Half of 4 is 2. So if we go 2, we're going to go down 2. So we can put a point here. We're going to go 2, we're going to go down 2 again right there. If we go over to 4, normally we square 4. 4 squared is 16. 4 times 4. But then what's half of 16? Because we're going to do half of it. 8. So we're going to normally go 16, but we're going to go actually only half of that distance. We're going to go down to 8. Down to here, -8. And this way 4, go down 8, just negative 8 there. Let's go ahead and draw our parabola now. So that's all you have to do to draw it. Let's try to sketch your parabola the best you can. For me, it's a hard thing to do on this, but you guys can do better on your paper. Oh, that one's not too bad there. I did good on that side, and this side was not so good. Make sure you put arrows on the ends. Always, use the space on the window that you have. Don't do just a little tiny little parabola up on top. Do use the whole thing. Okay, so now that we've graphed it, let's figure out what these three are. Axis of symmetry should be very easy. Do you see the line going right down through the middle? That's the y-axis. Now you don't want to say axis of symmetry is y-axis. That's true, but you need to write it as an equation. Any vertical line is always going to be x equals. So it's going to be x equals, in this case, x is 0 on the y-axis. So it's x equals 0. That's how you refer to the axis of symmetry, is by a line like this, x equals 0. If it's a line going straight across, then it's going to be a y equals. To figure out what the focus and directors is, we need to know, what does P equal? So what does P equal? That's the question we need to figure out to be able to know what these two are. So we got to come back up into our equation. Now, I'm going to erase this part that we did up here just to get rid of that work, so I can see both equations here. I have two forms of this equation. Here's where this equation is a lot more helpful than this one, because this one has a fraction in it, this one doesn't. So we know that this right here, this number is actually, remember from the form, it's x squared equals 4py. This number, negative 2, is the 4p part. So I could do this, 4p equals negative 2. And now all I got to do to solve for p is divide by 4. See how simple that is. So divide by 4, and I need to reduce that. Negative 1/2 is my p. So that tells me, from the vertex, which is at 0 here, I need to go down, because it's got to go, the focus has got to be inside here. It's going to go down, let me do a different color, a half. So just a half, which half of the box actually is 1. So it's going to actually be pretty close to 0 right there. It's going to be right in there. And so what point would that be as an ordered pair? X is 0 for it. And then you're going down just a half, so it's just a negative half. That's our ordered pair. That's what the focus is. The directrix line would do the opposite way, a half. So you go up 1/2. And so you're going to put a line, straight line going straight across, right along here. That would be the directrix line. So we can label this focus in here, directrix right here. I put DIR for directrix. And so what would this line be? If it's going straight across, flat line, that's always a y equals line. And it's y is equal to where it's going through, which is the 1/2. So y equals 1/2. That's it. All right, when we come to number 4, now 4 is a little odd because it's not in any form that we really want at all. We're going to have to adjust it no matter what. So we want to decide, well, do I want to get the y squared by itself, or do I want to get the x by itself? And that would be up to you, whichever one you think. Now, honestly, I think it would be better to get the y squared by itself. I think it would be easier, and also it's going to be easier to figure out what that p is again, to know what this focus and directrix are going to be when it's in the form of the y squared equal to. So let's get y squared by itself. To do that, we need to add this 5x to both sides. So let's go ahead and add 5x to both sides. That cancels the 5x's there. And so now that leaves me with I'm going to have to put it kind of up here, a 1/3 y squared is equal to 5x. And now I need to multiply, to get rid of this 3, I need to multiply both sides by 3. So times both sides by 3. So that cancels our 3's here. Now it leaves me with a y squared is equal to 5 times 3 is 15, so 15x. So that's a form we can use here. That's a good form. Now we could solve for x at this point. I could divide by 15 or multiply by 1/15 and get the other form as well. So that either way would be fine. But for this one, We know it's going to be opening, because of the y squared, it's going to be opening left or right, but does it open right or does it open left? Look at your A number. This 15 is kind of like the A number. It's not really, we can't really call it technically A because the y squared is being solved, but if that's positive, then it's going to open right. So it's positive, so we will be opening right. Our vertex, there is no H or K, so we know we're going to still be right there at the origin on this one. And we know it's going to open right. So I'm going to put a little table of values down. X and Y t-chart here. That's going to be helpful to figure out what some of those other points are going to be able to figure out how wide or how narrow this is. So as we start to think about it, I'm going to plug numbers in. Since the y is being squared, I'm going to plug numbers in for y because everything kind of switches here. We switched the x and the y, so I'm going to switch my input and my output. My y is now the input. So I'm going to put in, let's go one box, which is 2. If I put in 2, and I come up here and just do 2 squared, I'm going to come down over here and say, okay, 2 squared is 4. 4 is equal to 15x. If I solve this, I'm going to have to divide by 15. And so the x here is going to be a fraction of 4/15. 4/15. Now, we want to maybe see, okay, where is that closest to? 4/15. Is that close to a half? It looks like even less than a half. Maybe you want to come up to your calculator, do 4 divided by 15, just to kind of see what the decimal would be. 0.26 or 0.27, so that's pretty close to 0.25, which is a quarter, okay? 1/4. So when we go up 1, we're going to go on the y-axis, we're going up 2 actually, so 1 box, it's 2. We're going to only go a quarter to the right. Well, remember, half of the box is 1. We're really close to this y-axis. So just kind of put a point right there. We're going to do the same thing if we go down, we're going to go in because of symmetry. Let's go up to 4. Let's plug in 4. Well, 4 squared, with the y squared there, 4 squared is 16. So in this one, we're going to get 16. I'll do a blue. So we're going to get 16 is equal to 15x. And so when I divide by 15, it's going to be 16 divided by 15, which that's pretty close to 1. It's pretty close to 15 over 15. It's a little bit more than 1. So when I come up to 4, 1 is halfway, so we're going to put just a little bit more maybe than halfway. Not much. Go down to -4. We're going to go about halfway and maybe just a little bit more. So you can see now how wide this is. It's definitely a wider parabola than we've seen before because you have this 15. Let's go ahead and draw this wide parabola. We don't need any really more points than that to get the idea of the shape now. You can get another set of points if you wanted to by plugging in like 6. You could have done the same thing with 6. So that's the idea of the parabola there. To do the axis of symmetry, well, this time the axis of symmetry is the x-axis. So that's a horizontal line. It's going to have to be a y equals, because everything's switching again. Y equals 0, that's the x-axis. Focus point, we need to know what the p is. So to figure out p, we come back up here to our equation, y squared equals 15x. So if I think about it from over here, it's the same idea. 4p is 15. So maybe I'll come down to looking at it, I'll come over here. So I'll say 4p equals 15 on this one, and then I'm dividing by 4. So p is equal to 15 over 4. Let's make a decimal out of this. We could do a decimal if we want to. 15 divided by 4, that might be better to see it as 3.75. So 3.75 is our p distance. So if I want to do the focus point, okay, so that's going to be inside the bowl. Here's 4. 3.75 is going to be just a little bit right there, a little bit back from 4. Okay, and so that would be where x is 3.75 and y is 0. That's our focus point. The directrix would go 3.75 this way, so go towards -4, but not quite to -4. And then we're going to draw a line straight up, straight down. It's a vertical line. That would be our directrix on this one. And that line right there is going to be an x equals line because it's vertical. It's going through the x, which is 3.75. Now, number 5, this one looks really familiar to us. That's our vertex form all the way. We can identify the vertex first. This is what you always want to, when you see this form, what is our vertex? Can you see the vertex there? You should be getting pretty good at that. H is what? We're at -1 because it's opposite of what it is. And the K is -3. So let's plot that point. -1, -3. So negative, now remember, every box is worth 2. So -1 goes halfway. -3 is like right here in the middle of this box. Okay, so now we can go from there. We know, are we going to go up or down? And then we get x is being squared, so we are going to either go up or down. But a is negative, so we're going to go down. So we know we're going to go down from here. And it's a 2 for the number, which means we're going to go twice of what we normally would go. So if we, again, go 1 to the right, which takes me back to the y-axis, normally we go down 1, right? Because 1 squared is 1, but this time we're going to actually go down 2. 2 times 1 would be 2. So if I go 1 to the right, I'm going to go down 2 units. That puts me here. Go 1 to the left, I'm going to go down 2 units. That would be putting me there. If I go 2 to the right, 2 squared is 4. So normally I go down 4, but now I got to go twice that. 4 times 2 is 8. So when I go 2 to the right, we're going to go down 8. That's 1, 2, 3, 4, 5, 6, 7, 8 is right below our graph. Let's go ahead and put a dot there. 2 to the left, do the same thing. You'd be putting a dot right there below it. So this is a bit narrower. It's a little thinner. So we want to try to make it not a V. Try to do your best at making this a U shape. Mine's pretty ugly there, but you guys can do a much better job with your pencils than what I'm trying to do on this thing. It's hard to get these thin ones, especially the thin ones are hard. Okay, so there we go. So that's the shape, kind of the parabola. We want to see, okay, axis of symmetry is going to be going straight down. It's a line straight down, so it's an x equals line again. And it's x equals where it is on the vertex, which is -1. X equals the -1. That's how you refer to the axis of symmetry. Just x equals the number of the vertex for x. Focus, we need to figure out again what is P. So in this case, we have -2. But remember, this is the one where it has got the y equals. So it's more like this, where y equals, 1 over 4p. And then you have, your x squared part. So really, -2 is going to be this fraction. So we could say 1 over 4p is equal to -2. And now to get p, we need to maybe multiply both sides by 4p. That might be the easy thing to do there. By multiply, use a different color, by 4p. Oops, let's go with red. There we go. That gets rid of the fraction down below. And so I cancel the 4p's there. It leaves me with 1 on this side, and it leaves me over here with a -8p. So now to get rid of the -8, we just divide by -8. And so we can see now p is equal to a -1/8. So now for the focus point. Go from these numbers here. So your focus is going to go down just 1/8, just a little bit of the way. I'll put it down in there so you can kind of see it. So to get that point, we're already at -3 on this y. Okay, so x is -1. It's going to be the same x, still -1. It's on the axis of symmetry. It just went down 1/8 from -3. So now we're at -3 and 1/8. Just added a 1/8 to that -3 to go down a little further. The directrix line has got to be a line going 1/8 behind it, which is just barely behind it right there. So you got this line kind of going stretching across this way. Since it's going across horizontally, it's a y equals. But now it went back 1/8 from -3, so that would be a -2 and 7/8. Right? You take 1/8 away from 8/8, that's a 7/8 now. So -2 and 7/8 would be that number. Okay, so that was on 38. So the rest of it's going to be a little bit easier. That was definitely the harder part right there, is actually graphing them and identifying the focus and directrix is the harder part. Looking at 6 to 8, it's actually a little easier. So let's take a look at 6 to 8 here. All right, so here I'm just going to leave you with this. So let's talk about 6 here. I'll just show it to you what you should be doing. You want to write an equation. It shows you the graph to know, what we need to do, figure out what is the P distance from the vertex to the focus. You can see it's 5 units, positive 5 going up. So we know since it's opening up, we're going to use this kind of equation with the x being squared and just plug in P. So 4 times 5 gives you 20, and there's our equation. That's all you got to do. That's simple. So you can write very simple. It's got the origin right here. In fact, I think all of these, all 3 of these are vertex at the origin. So they're the easy equations to write. It's definitely a little more challenging when the vertex is off the origin. Number 7, it's opening sideways. So you need to know that you're going to use the one with y squared. Y squared equals the 4px. So just switch the x and the y from this one. That's all you're doing, switching x and y when you got it sideways. And when you figure out, okay, from vertex to focus, okay, it's actually going to be a positive distance because even though it doesn't show you the focus on this one, your focus is going to be over here to the right. So your P distance has got to be positive, but you should be able to figure it out from the directrix line that they give you, because that's the same P distance, it's just the opposite direction. So see how it says x equals negative 7/12? Well, positive 7/12 would actually be the P distance. So we're going to put in 7/12 for P. So 4 times 7/12, cross-canceling 4 and 12, and now it's 7/3. So y squared is equal to 7/3x. And you can leave your equation like that. You can leave it in that form. That's fine to leave it in. And then this number 8 one, again, it shows us the directrix. The directrix, they say, is 3/5. From the focus to the directrix, that's 0 here. Directrix is up 3/5. So really, the P distance is going to actually be in the negative direction. It's going to be a negative P. That will be a negative fraction at negative 3/5 for the P, because it's going down from the vertex to where the focus would be. You're going down, it's negative. So negative 3/5 is what you got to plug in for P on this one. We got the x squared one on here because it's opening down. So you're not switching the x and the y on this one. And so then you're going to say, okay, 4 times the negative 3/5 is a negative 12/5. So you're just saying 4 times 3 basically on the top, getting the 12. So x squared equals negative 12/5 y. Now I wrote it in the other form. If they, for some reason, they wanted it where it's got y equals, well, then we would just have to basically multiply both sides by the reciprocal of this fraction. You flip the fraction upside down. That would be multiplying by 5/12. So here's the other way you can write it. You can write it also like this right here. Y is equal to negative 5/12 x squared. All right, we just have one more to look at. This won't take long. But this is the one that talks about a cross-section. You can see right away in number 9. It says the cross-section of a parabolic sound reflector. So it gives it kind of more in the real-life situation here. So here I'll just let you see it. So we're at the Olympics. We got this sound reflector. It has a 20-inch diameter, and it's 12 inches deep. So the first thing as I did is I drew a coordinate plane. I want to draw this. It says that it says write an equation that represents the cross-section of the reflector, which would just be the parabola. It's at the vertex, so I put a point at the vertex, right 0, 0. It says its focus is to the left of the vertex, so I know my focus is over here. So I just put a point over there. I don't know where it is, but I put a point there in red just to show my focus is this way. That way I know my parabola has got to be opening this direction. It's going to open left. Now, the other information it gives me is that the distance here is 20, okay? From here to here, the edge of this reflector is 20 to each edge, so it's going to be 10 this way, 10 that way. And it's also going to be 25 out, because that's what it says here. It's 25 inches deep. So this from the vertex to here is 25, and then each way is 10. So I put a point here that I know that's on this parabola. The point is -25 and +10. I know that point. So what we can do here to figure out what the p is, we're going to use this equation with the y-square where we're switching the x and the y. I'm just going to put in these numbers for my x and my y. And so I'm going to put in for y 10, so 10 squared, which becomes 100. 4p times x, x is -25. So 4 times -25 is -100. And when I divide by the -100, I find out what p is. Again, you're just trying to figure out what p is to write the equation. So p is equal to -1. So now I can just plug that back into this equation up here and say, well, y squared equals 4 times -1. And that's just y squared equals -4x. And I can leave my equation like that. Or if I needed to solve for x, I could solve for x and change it. It doesn't matter. All right, so I just wanted to do this lesson with you. There's no assignment with this lesson. We just wanted to do the notes so we get an idea of what this lesson's all about, what the focus is really. That focus is like a big part of the parabola. I didn't want to skip over that. I thought you did need to see what this focus point was. So, but now, from now on, you can just go on to 2.4.